Okay, let's start with questions on any of the ones that you guys had for homework.
34.
34. Okay.
Like the absolute value.
34. Okay. What other problems did you have questions about? Come on, guys.
Where's my pen?
Which ones did you have questions about? That you actually tried? Okay.
I gave up.
So just 34. All right. Well, let's look at 34 then. Now you guys know that you're not allowed to just square both sides to try to get rid of a square root because we're verifying an identity. Okay, so if we're verifying the identity,
I tried squaring.
then we need to work with just one side or the other.
I just squared, yeah, I squared.
Yeah, you can't square both sides. So what could we do though?
Does it multiply like flip it thing?
What do you mean?
Because it's 1 minus multiplied by, like, you get rid of the denominator, like 1 minus.
Since it's so radical.
Or you could split it, like square root of 1 minus cosine.
Put square root of 1 minus cosine and then square root of 1 plus cosine? Is that what you're
I
saying?
don't know if it would do anything.
Since there's a radical on the bottom, we need to make it so there's none. So you multiply by 1 plus radical. Wait, don't you multiply by radical 1 plus cosine on both sides? Or?
Okay, and we're kind of doing that. Let's, for a moment, forget about the radical. Okay? And inside the radical, let's deal with the denominator. How do we deal with the denominator?
Multiply by the...
Yeah, multiply by the conjugate. So I'm actually going to make this radical bigger because this is all taking place inside the radical. So we actually are doing kind of what you were talking about. So we're multiplying by this form of 1. Okay? Now, let's simplify the denominator and then do what Joseph was mentioning about putting these in separate radicals. Our numerator is the square root of 1 minus cosine times 1 minus cosine. Well, that's 1 minus cosine squared, right?
Mm-hmm.
So what's the square root of 1 minus cosine
1 minus
squared?
cosine.
That's just 1 minus cosine. So actually, notice we have our numerator all set. So now we have 1 plus cosine times 1 minus cosine. What does that equal?
1 minus cosine.
Here we go, 1 minus cosine squared. And what's 1 minus cosine squared?
Sine squared.
Sine squared. Okay? So what's the square root of sine squared?
Sine.
Sine. Okay? And we include the absolute value because we want to make sure it's positive. Otherwise, we could be taking the square root of a negative number. We don't want to do that. Okay? So. Alright, so there's 34. Alright. Any other problems come to mind here while you're waiting? While we were looking at that one?
Is there any, can we do anything else with it?
or is it the end result?
Well, we got here, and that's what we were trying to prove.
Okay.
Now, it's possible you may want to simplify it some other way. I'm not sure exactly how. I guess we could write it as cosecant minus cotangent if we really wanted to. But, if it just said simplify and didn't tell us where to stop, then we might do that. But in this case, we'll just leave it there. Anything else?
I'm into 32.
32. Okay. Oops. Not that. Start this up. I'm going to scooch this down a little bit here. All right, 32. Now, look at the structure of the two sides. So look at how the two sides are given there. We have tangent plus cotangent over tangent times cotangent. So there's one term on the one side. On the right side, we have tangent y plus cotangent x. Two separate terms. So what would it make sense to do here first?
Return them.
Put them into two fractions.
Okay.
Yes.
Yeah, separate the left side into two fractions. Why would it not be a good idea to go with sines and cosines here?
And you get
Because
more
the answer
fractions.
isn't inside.
Yeah, we get more fractions and,
The answer isn't in.
yeah, the answer has tangents and cotangents in it. So, let's not introduce sines and cosines unless we're just totally stumped as to what to do. Then maybe we might go that route. But let's split this up. We would have tangent of x over tangent x cotangent y plus cotangent y over tangent x cotangent y. Now notice this is, you gotta pay attention here because this is the one where we have two different angles we're dealing with. So you have to pay close attention and you can't just write tangent like we do sometimes to save time. You have to keep the angles in the problem here because it makes a difference. So what would we do at this point?
Can't you cancel it?
Yeah, we can.
Tangent x, tangent x. and
Yep.
Cotangent y, cotangent y.
Yeah, so we have 1 over cotangent y there. Then we cancel out cotangent y and cotangent y, so we have 1 over tangent there.
It's just so it's just tangent plus cotangent.
Yeah, now we're using our reciprocal identities. 1 over cotangent is tangent of y, and 1 over tangent of x is cotangent of x. And that's what we were trying to get to. So we're done. All right. Are there any questions about that one? How we did any of that? Okay. Any others before we move on? What?
Yesterday the first.
What?
Yesterday the last one first.
Oh, number 30,
Yes.
where it had,
Oh, you're
Okay.
finish it.
that's right, we didn't finish that one, did we? What was the original one?
Tangent x plus tangent y over 1 minus tangent x multiplied by tangent y.
There we go.
Equals cotangent x plus cotangent y over cotangent x multiplied by cotangent y minus 1.
Okay, so this is a good example of one where it might be helpful. It might be helpful to work on both sides. Okay, when I initially tried this one, I ended up with like an entire screen full of stuff, and that was mostly just working with the numerator on this side. Okay, and it got really, really, really messy, and I realized that I needed to try something different. Okay, and that happens. Sometimes you're doing something that's perfectly legal, okay, but it just doesn't get you where you want to be. All right, so what I found in this case would be the best solution, particularly because we have mixed angles and things here, is I went ahead and put everything in terms of sines and cosines. All right, so here we have sine x over cosine x plus sine y over cosine y. So that's over 1 minus sine x sine y over cosine x cosine y. Alright, because we had the tangent of x and the tangent of y. Alright, Kenny, come on. Now, whenever we have mixtures of fractions here, we said probably the best thing to do is try to get one fraction in the numerator, one fraction in the denominator, and that would allow us to then flip and multiply, do the division. Okay? So, in this case, I'm going to multiply by cosine y over cosine y. And over here, I'm going to multiply by cosine x over cosine x. That will give me a common denominator for the numerator. And I'm going to end up with sine x cosine y plus sine y cosine x all over cosine x times cosine y. Alright? Now that's just the numerator. The denominator, it's easy to get a common denominator with. It's just, yeah. It's just that. So now in my denominator, I'll color code it so you can kind of see. I have cosine x times cosine y minus sine x sine y all over cosine x times cosine y. And you might notice that if I flip and multiply, the cosine x cosine y are going to cancel each other out. You see that? I have this divided by this, so if I flip it, this will cancel out that. Alright, let me do purple. So that cancels out that. And you'll notice sine x times cosine y plus sine y cosine x is over cosine x cosine y, oh boy, cosine y minus sine x sine y. Now, the likelihood of getting from that to the cotangent side is not very good, okay? Just coming up with a way to get there. However, a good strategy at this point would be to see if we can get the right-hand side by plugging in sines and cosines. See if we can get what we got on the left-hand side. Okay? Now, you guys have seen it done on the left-hand side. Why don't you try the right-hand side and see if you can get there. Okay? So take a couple minutes here and try it. The 1 minus, we used this denominator and just used it as a form of 1 to replace the 1.
How did we know that the sign only with so from this
We will learn that actually later on this chapter.
and this and we only know this is we can know in plus b which it's up to minus n one plus 1 plus o minus b
Okay. Now the only thing with that is we're not finding the tangent of two angles added together. We're finding the tangent of one angle and adding to it the tangent of the other. Okay. So we couldn't actually use that in this case here.
yeah, we can.
That didn't make anything.
This is so we can use this one.
Okay, so this will equal tangent of equals 0. Okay, but then does that work for cotangent?
Yeah, it's not what for the totangent. The totangent is 1 divided by tangent, so you just change this. The totangent will be this. Tangent is times tangent 1 minus 1 divided by tangent is plus tangent 1. We'll just change use 1 divided by tangent. So it's this
Would be 1
1
minus
1 minus
1 minus cotangent. Actually, no, it'd be 1 minus tangent. Because all you're doing, what you're doing is you're doing that and you're flipping this whole
yeah,
thing.
but why do this is what we write. But tangent x times y is sine x and sine x y is sine, and I just multiply twice the sine x and sine y. You need
Oh, so you did that,
yes.
and then you took. Okay, so basically you said since this whole thing equals tangent,
Yeah, and this will
then you kept going. You did 1 over tangent, which would be cotangent of that.
yes.
So then you did cosine over sine. So you did cosine e. Cosine cos. Okay, so then
Multiply twice and multiply the sine x, sine y, and it will be and it will be is tangent x times 1 minus 1 divided by 1 times tangent x
multiply the numerator and denominator
Yes.
by those?
Yeah.
I don't really see how that
Well,
would get you where you're going. I mean, what you're doing is a good idea, but
Oh, you multiply by one
Yeah.
over that. Oh,
Yes.
okay. I get what you're saying. And, okay, so you had cotangent x, cotangent y,
And this is 1.
and that's a 1.
Thank you.
Okay, minus 1.
And this will be tangent y.
Okay.
So it will be minus 1, not 1 minus.
yeah, and then that was cotangent.
So it will be.
Okay. Yeah, that worked. That's good. All right, do we have it?
Almost, I like one line. Cosine of sine.
Yes.
Should we try and get it back to like if we get them to equal the same, should we try and get it to equal the original thing?
No. It's just the flow of your proof would kind of be a U instead of just going down. You know, yeah. If you get the two sides to be the same, you don't have to like reverse engineer anything or anything like that. All right, let's take a look here. We plug in sines and cosines for everything. We get common denominators in the numerator and denominator. So the whole numerator will simplify down to sine y cosine x plus sine y cosine y over sine x sine y.
How come you multiplied by sine y and
Yeah.
sine y and not sine
Sine x.
x and sine y?
I was gonna ask.
Oh wait, sorry. Yeah, thanks. That should be x. That should be x. Thanks. So we're multiplying by forms of 1 to get our common denominators. And now you'll notice in our denominator we did the same thing. We used a form of 1
Yes.
to get a common denominator, sine x sine y. Then, once you have this, if we were to flip and multiply, this would cancel that out.
Where's the one?
The 1 is right here.
He transformed it into sine
I
x.
transformed it into
y.
sine x sine y over sine x sine y.
Should you
So-
always do that because you did it both sides?
To get a common denominator, yeah.
Okay.
How do you make it? How come the one is sine x? Okay.
Yeah, anything divided by itself is 1, and I wanted a common denominator. So now, you'll notice what I've got left. I have sine y cosine x plus sine y. Hang on.
Fire X.
Sine.
Oh, hang on. That was correct. That needed to be an x. There we go. Sine x times cosine y, and that's over the cosine x, cosine y, minus sine x, sine y. Okay? So, they're the same, so you can stop. And our proof, like I told Ashley, our proof just kind of follows a U to get one side to equal the other. Okay?
How do you mark your answer, like on the test?
You really don't. You just end up with two sides that are exactly the same.
No.
Alright, so if you guys have more questions on that, feel free to come by and I'll help you out with ones that you're having trouble with. What we're looking at though, that was, we've spent all of our time so far looking at the first two applications of trig, which are finding values of trig functions and then simplifying or verifying identities. Okay? So we're going to look at another one of our applications starting today. We're going to spend a few days on this, and that is solving trig equations. As we do different problem solving, this is probably the most applicable or the most practical application that we have. Okay? And there are a couple of things that I want to make sure that we keep in mind before we go through with actually solving these problems. Okay. So first of all, remember all students take calculus, alright? Remember what's positive in which quadrant and what's negative in which quadrant, okay? This should be firmly ingrained in your head, okay? You'll probably see that in your sleep at some point, okay, by the time we're done here. Okay, so remember that. Secondly, check the range of theta that the problem asks for. Alright? If you don't see one, assume that it's going to go from 0 to 2 pi. Okay? Assume that we want all the angles from 0 to 2 pi unless the problem specifically tells you otherwise. Okay? That's not an overall math rule, that's just my rule for you. Okay? Obviously, word problems, they may not specifically tell you a range for theta, but there are going to be natural ranges for theta. You know, for example, the old problem where you have a ladder leaning up on a house, okay, and you're trying to find the angle here. Okay, what's a natural limitation for what theta could equal?
Can't be made. Or
Can't be more than 90, can't be negative. So our answer is naturally going to be between 0 and 90, or 0 and pi over 2. Okay? So don't tell me that, you know, somehow we were leaning on the house by pushing it, you know, in an obtuse angle, okay? If your ladder looks like that, you're in trouble, okay? So, there are natural things within a word problem that might limit it, but especially when you're just solving equations, look for the range that it asks for. And often those are in the directions. Sometimes we ignore directions because we assume we just know what the problem is. Make sure you read directions carefully on these, okay? So let's take a look at how we would go about doing this. We'll start with one that won't require the calculator, but I want to use this to introduce how we're going to give our solutions, okay? Now, as we're trying to solve trig equations, so I'll kind of give you a step-by-step process that I usually follow, okay? First of all, if you have a mixture of trig functions involved, which we don't in this example, but if we did, try to get the equation in terms of one trig function. As we'll see later on in this section, that's not always possible. Now, how, if we're given stuff with tangents and cosecants or whatever, how would we get that all in terms of one trig function?
Turn
What?
them into cosine.
Okay, if we had like a cotangent squared, we could add 1 to both sides or something and make that a cosecant squared. Okay. Just using the identities we've been learning, right? If we use the identities we've been learning, we can transform the equation so that it only has one trig function. Okay? Secondly, isolate that trig function, or in other words, get that one trig function by itself. Okay? Then, thirdly, we want to use our inverse trig functions. Okay, use the inverse trig functions. So, as we look at our example here, we only have one trig function to begin with. Alright, so we're on to step 2. What I want to do is I want to get sine of x equal to something. So sine is by itself. Alright, so if I did this with the algebra, obviously I would add 1. Whoop. So I'd have 2 sine of x equals 1. Then I would divide by 2. So sine of x equals 1/2. Now, we're going to assume, since we weren't given anything else, we're going to assume that x goes from 0 to 2 pi. Okay? So again, now we're using our inverse trig functions, and we're doing it in our head because this is from our unit circle. What angle has a sine equal to 1/2? 30, which in radians is pi over 6. Or 5 pi over 6. Okay? So those are our two specific solutions for a given interval. Okay? These are specific for the interval from 0 to 2 pi. Now, a general solution is a way of expressing all possible answers. Okay? Now let's just take the pi over 6. What other angle looks just like pi over 6?
330. Okay, 390.
390.
Yeah.
Or, well, that would be 13 pi over 6, right? What did he do?
He just added
Made it
another-
nice.
Other two pi.
Terminal.
He added a 2 pi, right?
Yeah.
What do we call those angles where we have an angle and then we just go around another lap?
Coterminal.
Coterminal angles. Okay? So, our general form is a way of expressing all coterminal angles. Okay? Express all possible coterminal angles. Okay? Now,
Can you just keep adding 2 pi? and then add-
forever, yeah, there's an infinite number of these, right? So obviously we're not listing them here, okay? But it goes back to how did we get that coterminal angle?
Add 2 pi.
We added 2 pi. Alright, so x would equal pi over 2, or not pi over 2, pi over 6, plus 2 pi, and we usually use n, although it doesn't really matter, 2 pi n, and we would specify where n is any integer.
Could it be neg- can't be.
It can be negative, because remember, coterminal angles you could rotate backwards a full lap as well, right? So it can be negative. Okay? So it's that, or what's our other solution? Our other general solution?
Minus 2 pi.
5 pi over 6 plus pi and 2 pi n.
There we go. We don't have to do minus because n is an integer, so n can be negative. Alright, so we would have the 5 pi over 6 plus 2 pi n. Okay? And those are the general solutions for that equation. Alright, again, pay attention to the directions. Okay? They may ask for the general solutions rather than within a specific interval. Alright, so make sure that you give the solution that you're being asked to give. Okay? Does that make sense?
Yeah.
Alright.
安可以是让题目
So let's take a look at another one. Okay? Sine of x plus radical 2, whoop. Sine of x plus radical 2 equals a negative sine of x.
Isn't it just,
Sine of x
I
radical.
So what do we say we want to do first?
combine the
one
one
side.
trig function. Get the problem into one trig function.
We've got one trig function, which you already have, so that's done. Then secondly,
Combine the trig function.
yeah, we'll have to combine them because we want to get our trig functions by themselves.
So 2 sine of x.
Negative.
Okay, yeah, let's add, or yeah, we could subtract the sine over to the right hand side, so it's a negative 2 sine of x equals radical 2.
And then you divide by
Divide by.
negative 2.
Divide by negative 2, so it's sine of x equals a negative root 2 over 2.
So,
Okay?
it's way pi over 4.
That's a reference
No,
angle.
just kidding.
Here,
It's wrong.
everyone see how we
Oh,
got to
square
this
two.
point? This is just the basic algebra of getting sine by itself. Now,
It's,
Oh, you mentioned
So you just 3 pi over 4?
Yeah, 3 pi.
okay, which quadrants are is sine negative in?
Second.
No,
Or no, third.
3rd and 4th.
3rd and 4th. So it's not pi over 4, it's not 3 pi over 4. Those are where sine is positive.
5 pi
7 over
5 pi over 4
and 7 pi
7
over
pi over.
and 7 pi over 4. Good. Okay, so we would say x equals 5 pi over 4 or 7 pi over 4.
Isn't that one that we need to give the general?
No,
Because
Those
it's
there
all
are-
solutions.
Well, all solutions.
but also tell us we only can.
Oh, yeah, on the interval.
0 to
Yeah.
Yeah.
All the solutions in that interval, so we don't have to do the plus 2 pi n. Okay, we just have to do that. Alright, not too bad, huh?
No.
Alright, last example I want to end up with. Three tangent squared minus 1 equals 0. So we don't see an interval, so what would we assume it was?
It's 2 pi.
0 to 2 pi. Okay? Alright, so trying to get tangent by itself.
What do you see? Square root of 1/3.
Okay, tangent squared of x equals 1/3. Alright, add 1, divide by 3. And then, like Joseph said, we are going to take the square root. Now, what's one rule about taking the square root in an equation?
Plus or
Both
minus.
sides.
The plus or minus. You got to do it to both sides, you're right. We have to have a plus or minus.
What?
Square root of 1/3. Okay?
I couldn't hear what you're saying.
Now, what is the square root of 1/3? Rationalize.
Good question.
Rationalize that.
Root 3 over 3.
Root 3 over 3. Okay? That's something that we ought to recognize, even if we don't remember exactly where it came from. Okay?
Wait, what?
That's from our unit circle still.
That
Oh,
makes
because 1/3 is.
Does anyone remember which reference or which angle that was?
Minus
Minus
tangent.
Yes. So sine over cosine equaled root 3 over 3.
Power 6, 13. And
It's either pi over 3 or pi over 6, right?
Yeah.
Yeah.
So
I have no idea.
let's think about it. If we had 1/2 divided by root 3 over 2, or is it root 3 over 2 divided by 1/2? Which one is it?
First.
first one.
It's the first one. So sine is 1/2, cosine is root 3 over 2, right?
Yeah.
So what angle is that?
Pi over 6.
Power 6.
Pi over 6, okay? Now, here's where this one we have to be careful with. Because a positive root 3 over 3 gives us x equal to pi over 6 like we just saw. Or where else is tangent positive?
7 power 6.
Yeah, the third quadrant,
Oh, that was
7 pi over 6. Okay? But we can't just look at the positive one. This is a problem where it's really easy to lose half your answers. Because we also need to look at a negative root 3 over 3. And that's going to give us x equal to
5 power 6.
5 pi over 6, or,
11 power 6.
11.
there we go, 11 pi over 6.
So we have 4 answers for that?
Okay, so that one we have 4 answers for. It's a quadratic, which means there are 2 answers for tangent, and each of those gives us 2.
So every time
Answers.
you have like a square, you're gonna have the 4 answers.
Yeah, unless we have one of those quadrantal
Yeah, that
ones.
makes it easier now.